All right, boys and girls, welcome back to the drive-through. Hope everyone's having a great day. You're going to really want to pay attention to this lesson, so quiet down, and you might want to watch this video a couple times, okay? I know you've already been taught this, but this is the problem with your parents being in a hurry, and that comes with being an accelerated. It's a great track, but sometimes you're not mature enough to understand what you're doing. So sometimes in algebra, you actually turn into computers. All you do is learn how to do something. You get very good at repeating that thing, and that's what computers do. You don't really understand what you're doing. You're just good at the process. Okay? It's no one's fault. It's not your teacher's fault. It's not your parents' fault. It's just the way your brains work. Hopefully with a year more of mathematical maturity, you'll understand this at a whole different level than you did last year. Okay? So, I want you to first start thinking by, how did we get here? Last chapter, we spent it all on similar shapes. Pretty much all of it on similar triangles. Do you remember that? Yeah. And then, now we've gotten into right triangles. Specifically, we've learned some special right triangles. And then the next thing is SOH CAH TOA. All of these things are related, and if you can think about the math history of it, you'll have a much better chance to understand what the heck you're doing when you pop these things in your calculator. Okay? We will not be using trig tables, as I said to you. We're going to use our calculator. So, at first, someone was like, you know, these 30, 60, 90, and 45, 45, 90 triangles keep popping up. So I'm going to memorize the ratios of the sides. Do you understand that's what you've done? Well, then someone else came along and said, you know, I think it would be advantageous for us to memorize, and I put my hands in quotes, all of the ratios. How do I know that the ratio between A and B in this triangle is the same as the ratio between X and Y in that triangle? Sush? One angle? Two angles. And therefore these triangles are what? And corresponding sides of similar triangles are proportional. See, now you understand all that stuff. So we know for sure that A over B is equal to X over Y because these triangles are similar. You got it? Well, that person was just like, hey, I'm going to make a list. I'm going to make a huge list. How many right triangles are there? There are infinitely many right triangles. So this guy made an infinitely long list because remember, there's a 30, 60, 90 triangle. There's also a 30.1, 50.9, 90 triangle. There's a 30.01, 50.99. You follow me? So he's like, well, how am I going to keep track of all these? Well, he made an organized list. Now, the language was different back then, so he came up with some funky terms. So if we've got triangle A, B, C, and then you'll often see this referred to like that, okay? So what is the sign of A? He made up this terminology sign. Anyone? It's A over C. Okay? What is the cosine of A? And what is the tangent of A? And then he stopped there. He's like, that's all I need. Sine, cosine, and tangent covers every ratio that I could possibly form in this triangle. Okay? Now, what is the sine of angle B? B over C. Okay? What is the cosine of angle B? And the tangent of angle B? Okay, so far so good? Now, if you weren't very good at calling those out, then maybe you don't remember this acronym. So we all should write this down on the top. You should write your 30, 60, 90 triangle, your 45, 45, 90 triangle, and your SOH CAH TOA. You should write that on the top of your test. Okay, you should write it on the top of your homework. So, SOH CAH TOA. It's just an acronym for us to remember sine, cosine, and tangent. Okay, so far so good? Now let's go back to our picture. What's the relationship between angle A and angle B? They're complements, right? So in your calculator, I want you to type sine of 20. Type it in. Okay? Now make a note of what you got. Just a mental note will do. Now type in cosine of 70. Your mind should not be blown anymore. What did you get? The same thing. Does that make you feel good that you got the same thing? Look at this. What's the sine of A? A over C. What's the cosine of B? You better get the same thing. Does that make sense to you? Okay? Does that make sense? Bless you. All right. Next slide. So, stop. Put your calculator down. So what's the tangent of 45? I can't hear who said it. Sam? What do you think? Do you think it's 1? Okay. You think we only have one value, but what is this? And what's this? Okay. And how is A related to B? They're the same. And what's the A over B if A equals B? So now type in tangent of 45 in your calculator. Does that make sense now? You should all understand and be able to explain why the tangent of 45 is equal to 1. Okay? We still good? Caitlin? Okay, you're in radians. Anyone that didn't get 1, I need to help show you how to change your calculator into degrees. That's one of the most important things I can show you, okay? So I'll get to that. All right, so what I've attempted to do here is draw a 189, 90 triangle. Okay? And just so you know, this angle is actually probably more like 6 degrees. It's really hard to draw a 1 degree angle. But I want you to consider this 1 degree angle, okay? What do you notice about the side that's opposite from the 1? It's really small. Okay? Does that make sense to you? What do you notice about the adjacent side compared to the hypotenuse? They're really close. Which one's longer? What would the angle have to be for the adjacent side to equal the hypotenuse? It would have to be 0 degrees. So type in cosine of 1. Do you get something that's very close but less than 1? Okay, now type in cosine of 0. Does that make sense? If the angle is 0 degrees, what has happened to this opposite side over here? It's gone. So what has happened to the hypotenuse? It's not a triangle, exactly. It just folded and collapsed onto the adjacent. So now do sine of 1. Do you get something that's almost what? Almost 0. Now do sine of 0. Got it? Okay, now do cosine of 0. Sorry, do cosine of 90. My fault. Cosine of 90. Does that one make sense? That would just be this picture. Again, that's not even close to 89 degrees. But do you follow me on that? It's just this picture flipped. Do you understand why the cosine of 90 is 0? For the same reason that the sine of 90 is 1, if you want to try that. Okay? Alright. So how in the world do I use this? Right now, you're going to use these. First of all, in the real world, this is so used. Like, namely, your phone. So have you ever heard of triangulation? Is that the right word? Triangulation is literally using sine, cosine. Well, it's using the law of sines and the law of cosines, which we'll learn later. But literally it says if I have a triangle and I have 3 pieces of information, I can figure out any of the other 3. And that becomes very important. For instance, your cell phone knows exactly how far it is from the tower and how far the tower is from the satellite. Then your satellite just calculates the angle that we just formed, and that's how it figures out where in the world you are at all points. That's your GPS. That's literally how it works. It's just triangulation with 2 points, 3 points. You, tower, satellite dish. Okay? One of those things stays stationary, which is what? No, the tower. Okay? You and the satellite do not stay stationary. You might, but that's your problem. Okay? Got it? Alright, so if we want to find a missing side, what types of pieces of information do we need to know? Well, first we need to know that it's a right angle. We also need to know what? One angle and one side. Okay? Something like that. So, according to the angle, that says 21 degrees, not 210. What is the x? Opposite. What's the 10? Which one involves opposite and adjacent? Tangent. So tangent of 21 is x over 10. I tend to just turn these into a proportion and do x is equal to 10 times the tangent of 21 divided by 1. And so what is that? Give it to me as a decimal. 8386. Okay? Does that answer make sense to you? Yes, absolutely. I expected x to be less than 10. Why? Yeah, it's across from 21, so this one is, what's 90 minus 21? 69? So which side did you expect to be significantly bigger? That side. The side that's across from the big angle. Those kind of things are the most important things of this section, is that you know what you're doing. You shouldn't get a question wrong, because if you do, you should be like, hold on, that doesn't make any sense. Okay, so what do I need to know to find a missing angle? I need to know it's a right angle. Well, then I need 2 sides, okay? Okay? According to the x, what's the 60? What's the 50? Which one involves opposite and hypotenuse? So do sine, just bear with me on this. I know I'm an idiot and I know I make mistakes all the time. Okay? Just follow through for a second. How do you get rid of sine? What's the inverse operation for sine? Sine inverse. They stop getting creative at that point in the world. But if I do the sine inverse of one side, I have to do the sine inverse of the other side, just like all other. So x is the sine inverse of 60 over 50. Pop that in your calculator. So why is it telling you it's a domain error? See, I told you, some guy just typed all these in your calculator. If it doesn't work, he didn't type them in your calculator. I mean, literally, someone typed them all in. It wasn't your calculator, it was the chip that's in your calculator. Someone just programmed them. It's just a humongous list. It's the same list as what? It's the same list you used last year in math, that you guys were all like, I need my list.
is there any way you could maybe let me use my list?
And I was like, no, no, use your calculator. Okay? So, let's do this problem over again, but let's make this a 10. Make it a 10. Okay? And make this a 10. And make this a 10. And what's the sine inverse of 10 over 50? Thank you, Eric. 11.54 degrees. Does that answer make sense? Heck yeah. Okay? You understand what you're doing now? Okay, so you have nothing else to learn, but you have a whole lot to do. Okay? Because what is power? Wrong. Wrong. Knowledge was once power, and then what happened? The internet happened. Now knowledge is worthless. It's worthless. Okay? Ability is power. Ability is power. So all of this knowledge I just gave you is free because it's worthless. Boom!